Okay. To avoid running completely late, let's begin. So, welcome to the Data Challenge Award ceremony. I am Sampo Savolainen, as mentioned, and it's been a great 2 days and a third one today. To see all the great presentations by all the teams who successfully completed the challenge. We had 3 challenges. One of them was the Commuting 2.0 challenge by Vaisala and the Finnish Meteorological Institute and Spatial, and it's been really great to be part of this process to see what kind of ideas there are and develop these ideas around Inspire and get the data to be used. The other challenges, one was by Helcom, which was about how to find the best location for your seaside vacation, which was a very exciting new case, and as yesterday was discussed during the presentations, that this is sort of a novel use case for Inspire data, that Inspire is not just for boring, grey, authoritative stuff, but it can also be used, could be used for leisure activities as well. And then we had the JRC challenge about how to make JRC really work and test out the whole infrastructure. Did it work? Excellent. So, yes, perfect. So we will start now with the prizes from our partners and from the exhibitors. So the first one is gift packs. Come on, Manuel. And the National Land Survey is giving out gift packs to all the participants in the challenges. So if you participated in a challenge successfully, please come up. Dean, I can see you. Shikung, Jake. Where's everyone else? Where's the National Land, not National Land Survey, the Statistics Finland? Statistics Finland. Ah, perfect. Are we still missing anyone? No? Bus. Perfect. So come up to the stage. Don't stand in the sidelines. This is for you. So, like I said earlier, you all did a great job and you were able to complete the challenges in a tight time frame. We had a month, but we all know that people have jobs, people have other things to do and not just work on the challenge. Unfortunately, we would love to get... Next time we'll try to get your places of business to give you 1 month of free time to work on these. Yeah, and everyone in the teams is getting these packs, not just the people who made it here. Yeah. And then please don't go away. You can move maybe to the side and then wait for the next phases. The excitement builds up. Then next up, FME and Conterra are giving out a prize, a free entry to the FME user conference in Vancouver and a free entry to the Conterra FME days. So the big reveal.
Yeah. So we want to honor usage.
Yeah, there we go.
So we would like to honor the usage of FME in that challenge, and well, the winner is it's Bars, I think it's his first name, right? But,
Better wet from sweat.
Better wet from sweat. Next year, and also for Wow, thank you very much.
Unfortunately, Boss's other team member who was here had to leave very early this morning, so I guess, Boss, now you have to buy an extra luggage. And then we have Esri. Is Jill here? So Esri is giving away 2 prizes. These are tickets to the Developer Summit in Berlin. Jill?
Hi, everyone. These were really terrific challenges all across the board, and we're pleased to present 2 registrations for the Esri Dev Summit. First place winners.
The second place goes to
Second place goes to
Team
Team Statistics Finland for 1 registration for the Dev Summit. The Dev Summit is November 4th to 6th, so if there's issues with the date, we also will work with you guys for next year.
And first place goes
First place goes to Team Better Wet Than Sweat from Sweat.
Okay. Thank you very much. You did a great job, both of you. And then we will move forward with the actual main event, the awards itself. So we had a jury who evaluated all the submissions that we got at the deadline. So we were made up of the local organization committee as well as all the challenge partners involved with the particular challenges that the teams made. We had 4 criteria: relevancy, of course, whether the submission was relevant to what was asked for in the challenge, the creativity, how novel the idea was that they were presenting, the potential means how much of an impact in society or whatever use case it might have if this would be developed further on into a proper application or a useful tool or a more widely available tool. And then presentation, how well the ideas and the submission was presented. But we also then evaluated yesterday when the teams were presenting their challenges, and then last evening we got together, had a big fight, hopefully no bruises, and then looked over who got what, who won, who was maybe not as good, but everyone was good, so don't worry about it. So third place goes to Statistics Finland. There's a diploma for Matti and for Tuuli. Congratulations. Then comes second place, almost first, but not quite there. Team West Coast Surfers. Congratulations. Did we get the team name right?
Yeah.
Yeah, perfect. Oh, sorry. The rest of the people in your team,
Sure.
you need. And then we have the final. Who got it? Minerva! Congratulations. There's the diploma for you, Sharon, and everyone else, the whole team, and also the winner has to get something special. And next we will hear presentations, short presentations from all the 3 winning teams. So first up is Statistics Finland. So the microphone is.
Yes, thank you very much, and thank you very much for the organizers and the challenge partners as well. It's been a fun challenge, and as said, my name is Matti Kokkonen, come from Statistics Finland. I've been working with this work with Tuulipilemma, and yeah, we want to find the best seaside vacation spot for you. And this is, we did a data challenge, or data analysis. It's not an app as such, yet at least. And we wanted to do this challenge because we wanted to use machine learning algorithms for classifying. And we were originally going to use supervised machine learning, but we struggled to find suitable datasets for training. So we ended up doing unsupervised learning. And in our solution, we combine traditional geoprocessing and distance matrices. And as a result, we classify the whole Baltic Sea coastline into 5 different categories. We only used 4 different or 5 different data sets. We used the Baltic Sea grid from Helcom, urban land use layer, bathing sites and sandbanks. So our holidayer just wants to know if there are people or not, and if there is places to swim or beautiful beaches. And then we used the coastline layer from Eurostat to actually get the unified coastline. These are programs that we use: QGIS, SAS, scikit-learn package for classifying or clustering, Esri product for presenting. So first we needed a coastline to actually do the analysis on. So we used the Eurostat or the coastline from Eurostat website to define the coastline grids. So we got we used a buffer on the coastline, so we got about 2 or 3 kilometer or 2 or 3 cells on the coastline to populate with data. And we populated with information if there is a beach nearby or not. And then we also divided the urban land use layer into 2 different categories. If it's suitable for holidaying, there are dwellings, hotels, stuff like that, places where you want to be, and places which are unsuitable for holidaying, which are yellow, and those yellow areas have ports, industrial areas, and so on. And then we calculated the distance from bathing sites, sandbanks, to the grid cell centroids, and then also to the closest feature on the urban land use layer. And if there was no match on the urban land use layer, the area on the grid cells was considered to be unpopulated. This is the data set that we used. So we took out the actual data from the location, and we used that for clustering. So we left the location, the rest, and then we took it out to another program. So we used, as I said, we used unsupervised machine learning, the k-means algorithm from scikit-learn. It's a Python package, and it tries to cluster the data in as many clusters as you tell it to. So we adjusted the number of clusters into 4 different clusters, since we had basically only two different variables. And we got 4 different categories. One was urban areas nearby and there is no beach, urban areas nearby, beach nearby, and then remote areas with beach nearby and remote areas where there is no beaches. And those classes you have to give after the clustering, since the clustering itself it only does the classification, the clustering, but it doesn't give the labels. So you have to look at the data to give the labels. And here are the results. In total, we had 59,400 coastal cells, and most of the cells had a beach and an urban area nearby. Of course, it varies by country. For example, Denmark, Germany, Latvia, Lithuania, and Poland, they mostly fall into category with beach and urban area nearby, and Estonia has the biggest number, or relatively biggest number of areas with no urban area but beautiful beaches. And if you come to Finland, you will find areas with no urban area and no beach. So if you want to be alone, you should come here. And 7,000 of those cells were deemed to unsuitable for holiday. Here are the results on the map. So as you can see, we have classified the whole coastline. And we also have prepared a use case, which we can go through. I want to spend my holiday by the sea, but I don't know where to go. I have a few preferences. Since I'm a Finn, I would like to get away from people on my holiday. Would like to have a beach nearby though, and I would like to travel eco-friendly, so I would like to use my bike, so it has to be close. And the starting point of my journey is Kalasatama area in Helsinki. So I do my analysis. I select areas which have no urban areas nearby, but have a beach. And I get two alternatives which are within biking distance to Helsinki. One which is in Kappöle in Loviisa, which is 83 kilometers. And there is one in Vetlax in Raasepori, and that's some 140 kilometers. So I choose the closer one. And what should I expect when I go there? Luckily they have the marine protection area nearby, so I should be able to see a lot of different animals, seals, velvet scoter, razorbill, all of these different birds. And they should also have coastal lagoons and reefs if I want to go for a dive. And I also checked Airbnb, so they have places to stay. So it seems like a good area to go to. And if you want to take a closer look, we have prepared a story map, which you can review, and there are our contact information. So what I want to say, I want to thank you, and it was a really fun challenge, as I said already, and I hope this will become like a tradition in Inspire conferences. Thank you.
Thank you. Thank you. Please stay nearby. We will take a group picture afterwards. Thank you for the presentation, and thank you also for the great vacationing commercial for Finland. Not many beaches, but it looked like a pretty good beach, so maybe not quantity, but quality. So next up, Team Safe Software, Dean Hintz. Take the stage.
Thank you. Just like to thank the National Land Survey of Finland for being such great hosts this week, and then of course the JRC for having the vision to put on the event and making it possible. So I'll just briefly keep track of the time here. Give you a quick overview of our project and a nod to the help that Laura and Trent gave me with this one. And basically even though we're from Canada, I guess Canada is maybe disproportionately represented for a EU event, but hey, we have a new, I guess a new treaty with the EU, so it makes sense. But one thing that it kind of unifies all of us are the impacts of climate change, and so that's what kind of raised my interest, and managed to come across some good data sets over in the UK as well as some here in Finland. And you'll see from this story from the BBC that even this month, if this is from October, there's quite a few floods going on in the UK, and we have similar events in Canada as well. So one of the biggest impacts, obviously, with climate change is extreme weather, and usually one of the bigger impacts from that is water or flood damage and coastal inundation, more so even than, let's say, wind and other hazards. So there's lots of great data out there, but we just wanted to do something really quite simple. It's not that sophisticated. We're not doing a lot of advanced analysis or forecasting, but it's kind of allowing, getting that great information and making it publicly accessible. So some of this data comes from Inspire base maps, and some of it is provided by the UK Environment Agency in terms of the actual flood warning data, which is real time. So the idea there is you're leveraging the Inspire data, but you're enriching it with real-time information and making it publicly accessible. So ultimately, we want this to be accessible over the web via mobile devices as well as in people's homes on their computers. I would say at this stage, it's probably more tablet-friendly than mobile-friendly because I've played around with it on my phone. It's a little hard to actually interact with. But before I forget, I'll do mention that anybody wants to play with it, you just go Google FME Server Playground, and it's about the 5th one down, so you can see if you can crash it. All right, so in terms of the data sources, I should have put some logos in here, but the historical flood information for here was from the National Land Survey of Finland via their WFS3 server. And I don't have historical flood data in the UK other than what the system is generating. So what happens is every night, the system updates every hour based on current flood information. And then every night it gets cached to history tables. So over time, it'll develop its own history. And then the road networks and the infrastructure data, that all comes from the UK Ordnance Survey. And they have a new open data format, which is basically what I call Inspire Plus. So it's all Inspire, it encompasses the Inspire, full Inspire standard with some extensions unique to the UK. And the purpose for those data sets are for the impact analysis. So it's fine. The UK Environment Agency, you can go to their website, and they have flood information you can get directly. But what's difficult is then, well, what does it mean to me? So what does it affect? And being able to get customized information where you can interrelate the data to something that concerns you, that to me is key. And the system is designed so that you can easily add new impact layers to it. So it's just a few snapshots of where the data came from. I got into more detail in the actual data challenge presentation yesterday. There were some challenges actually getting to the data because the flood warning areas, all these data sets have records in the Inspire GeoPortal, so that's on the plus side. The challenge was that most of them didn't have any links to the national level data portals. So we had to, basically we had to Google to get to it. Yeah, there's the UK Environment Agency. That's their interface, which is fine for certain use cases, but it's great that they have also a published API so that you can extend it. And it's actually very WFS3-like in terms of how they deployed it. There's the open roads data. This is just showing that if you search for open roads, you get 21,000 hits, so you have to figure out how to find stuff. So I won't get too much detail on that. Kudos goes to the UK Ordnance Survey because you can basically download all this data and work with it. And so in terms of accessibility, that's great. Of course, the sheer volume can be a challenge because you have to filter that out in order to actually, I think I downloaded about 5 gigabytes of data. In the end, I'm only using about 50 megs. So this is just the quick architecture diagram minus all of the scary screenshots I had on Tuesday in there. So basically the flood warning rest service is kind of WFS3-like. And so basically the two orange boxes are FME running on FME server in the cloud on Amazon AWS services. And they are constantly polling for new flood warnings and then loading a staging database in GeoPackage. And the base map stuff, that's just a one-time load of the base map data. That could be refreshed as it needs to be. And then there's the client is just a web browser running JavaScript and Leaflet. And when the user makes their selections, that there's a REST service on top of the FME Cloud instance for the database that generates HTML and web map reports. So for those of you into FME, you can get the workspaces from me if you want. And we'll make those available on our knowledge base as well. So this is the extract and load into GeoPackage, and basically reading the GML, writing to GeoPackage. And there's a few of those. And this is our kind of prototype WFS3 server for reading in the National Land Survey data. So the core of this is HTTP caller, so you can wrap up almost any API and consume the data. And then I won't get, let's go through every transformer on this one. No, you'll be here all day. No, I just wanted to highlight here to add a new impact layer that says infrastructure. So all I do is basically duplicate a couple of transformers here, and I can add a new impact type. So I add a new feature reader and a new spatial filter, and then tie into the output, and all that information will flow to the web form. So just to wrap up, basically feel free to play with it. You can go, I only have impact data in central England. The flood data covers all the UK and the historic flood data for the southern half of Finland, but we'll probably add to that as time goes on. You basically just click a point, say what your area of interest is in terms of buffer, and if you say impact type none, then you get the flood areas in your area, and if you are interested in impact type roads or infrastructure, then you get a report like the one on the left where you can see whether you need to pick up your kids from school. All right, that's basically it. So I'd just like to thank the organizers for giving us the opportunity to participate. Normally, like we're a software vendor, normally we support our users. This time we had a chance to be users. And those are some of the conclusions. You can always download the deck. But overall, there's tons of data out there, and I think Inspire gives us a good infrastructure as a starting point. There are some challenges with how to locate the data, aggregate, filter it, and deliver it. But I think this was a good exercise in actually looking to make practical applications that can actually make a difference in people's day-to-day lives. Because often you see in the news, when you see people impacted by things like floods, you just think, I'm always thinking, well, if only they had better information, they could kind of get out and not be in the traffic jam the day of. Yeah, that's basically it. So feel free to come bug me if you want more info. I think the key thing for all this is just, how do we make Inspire usable and develop APIs and data services that are easy for developers to deploy to the public. Thanks.
Thank you, Dean. Can you give me the clicker? That was not part of the awards. Okay, so next up is the winner. Where is Jake? Perfect.
My slides, could I just demo the
Sure.
application? I went through all my slides yesterday, and I think I wouldn't know where to start.
This is always the moment of danger.
Technology always works.
Technology always works, as we all know. When you do a presentation, do you have a hand for a microphone?
Yes, I will make one. Beautiful. Okay, well, thank you. I want to start by thanking everyone for participating in the data challenge. I wish there had been more people that had come together and participated, but it's great that there was so many people representing not only the European Union, but also Canada. And I want to thank all the people who supported us in the project. So everyone at We Transform who helped us with some of our alignments, Alex and Marco for the support, and also Danielle from the JRC who helped us with setting up our registry instance. That was a huge support. And obviously thank you to everyone in my team that supported me and made this project possible. Right. So this is our, oh geez. So we basically took our project report, which we'd submitted to the JRC and to the project, and basically replicated it and made it into a website. So a lot of the information about what we did is available for anyone who wants to take a look at what we did and share it with anyone who might be interested in seeing Inspire in action. So yeah, you can see that one of the main parts of our project was to actually extend Inspire. So we took the natural risk zone classification and extended it to include 48 different landslide types. We did so using a tool that we have called ACE, which allows you to specify the properties of classes, and then it will structure a hierarchy. And then we took that and put it into the registry. The other thing that we did was we also created a extension to the natural risk zone schema to include the susceptibility feature type. So I think that there's a diagram of that. Here you can see how the susceptibility area feature type fits in with the rest of the natural risk zone core schema. So we also have some links about how our application is working, what's happening under the hood in terms of our cognitive reasoning system, the AI core of this project. And there's also all of our input data sets that we got. Most of them came from the Veneto GeoPortal, but some of them were aligned to Inspire. And we also have a link to all the tools that we used. Some of them are open source, but Hail Connect is proprietary, and some of them also came from the JRC. So registry isn't listed here, but that was a really important tool for our project. So I think I'll just jump to the application. So I think we now have a disclaimer here. And if you click through, what you'll be shown immediately is the slides and soil model. So we're showing susceptibility to slides and soil across the region of Veneto, and we can switch which susceptibility map we're looking at. And really what you want to do is you want to drill down and find an area that you're interested in, or if you don't have an area that you're interested in, I would suggest taking a look at one of the purple polygons, because those are the highest ranked in terms of susceptibility. And you can click on one of those and you'll be able to show the different runouts that have been simulated using the RAvaFlow tool. If you want to learn more about why that location was given the susceptibility ranking that it was, you can open the match report and you'll see a description of, on the left-hand side of the location, the instance, the spatial feature, and then on the left-hand side. On the right-hand side, you'll see the location and the model on the left-hand side with all the properties that we're looking for, in this case, in a rock slide. And then all the green bars are where we're matching the attributes. And you can kind of drill down further and get an explanation of why the score was given, because that's based on some of the frequency multipliers and also based on the hierarchies that are being used in the code lists that are really underlying this data. So I think that if you take a look at this, you'll see why Minerva is pushing so hard for the code lists within Inspire. It's what we really see value in. The data structures in Inspire are allow for interoperability, but it's the semantics and the standardized vocabularies that are available through the code lists that really provide a lot of value to AI applications. Yeah, thank you very much. Yeah.
Thanks, Jake. Now we should take a picture of all the winners. Do you have your prize, Jake?
Yeah, I can go grab.
Please go grab it. Do we have the photographer? Come on stage, please. Where is Dean? Dean is coming. Maybe we should stand up, I think. It looks weird if we're sitting down, and then there might not be enough. So maybe Jake in the middle. Maybe.
Do you want to, Clinton? Clinton should come up as well. He was part of our team.
Okay. Come up. Soren. Perfect. You don't have a fisheye lens? Okay. Excellent. So thank you to all the teams, and thank you also all to the partners who had the great ideas for the challenges and were willing to help the teams go forward and get great results and these interesting use cases. I think this was a really good practice for Inspire in the future, and I truly hope that JRC will keep pushing for such challenges in the future Inspire conferences. Especially, I think, because it's good for especially data providers to sort of dog food their own services. This was an opportunity for people who might just be making the data or making the services, doing the harmonization, to actually use that data to see how it works, what is the perspective of the data provider. But, you know, typically one of these things always have some problems with technology. There's a field.
Yes. Indeed, one more thing we want to mention in this session. I know that we are here for Inspire, all of us, so we care about our data, we care about our technology, we care about standards and about a lot of other things, but I think it's important to emphasize that we're a community, and the community aspect is probably the most important thing about Inspire. And considering that fact, we as JRC, together with the local organizing committee, would like to share one more thing. We're going to show one picture. For those of you who are fans of Game of Thrones, you would immediately recognize it, but it's not here because of Game of Thrones. This is Dubrovnik. As you know, this is where the next Inspire conference will take place in May. So what we would like to share with you, considering the fact that we're an inclusive community from day one, from the co-creation of the data specifications, for the collaboration between different actors in Inspire, Given the fact also that all the teams did such a good job, we would like to invite one representative of each of the teams to attend the next Inspire conferences, up to the teams to decide who that would be, and we will be covering registration there together with the local co-organizer of the Dubrovnik conference, as well as travel and accommodation. Before returning the mic, I think they did all a good job. Let's give them another round of applause. They really deserve it.